believer in not editing as much.
I'm also
So
recording.
hi, here we are. We're recording, which is great. I've got somebody with me who I think is one of the best people to speak to about the following thing. I get a question from a client at least once a week, worried about what their friends are saying. Their friends are ignoring how good the person that's sending the message looks, the fact they're off meds, their body composition's got better, their blood pressure's down, blah, 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 whatever. Doesn't matter. Their friends have these questions. So this person said, when someone finds out that I'm eating this way, these are the top questions. Could you get somebody to go through them and answer them all? So I thought, well, I know who I'm going to ask. The man in the house coat, Bart K, because he likes this sort of stuff. So
Yes.
hi, Bart.
Hello, good morning. Yes, today I shall be mostly wearing this house coat. Yes, I shall. It's 7 a.m. here in New Zealand in the middle of winter, and it's not warm. So I thought, sod it, I'm going to stay in the house coat.
Yes. Well, it's the middle of summer in the UK and it's not warm. So, right. So for people that don't know you, why should I be talking to you about things to do with the heart, for instance, and health?
Right. Well, I guess because, well, two things. Number one, I spent a couple of decades working in academia previously in another life. And I had a number of specializations that I was working in terms of teaching, researching, and consulting. One of which was the physiology of rest and exercise. Another one was human nutrition. And the third one I spent a lot of time around was cardiovascular pathophysiology, what causes heart disease and such and what doesn't. And all of that is overarched, I guess, by a fundamental, pretty good understanding of research design, statistical inference, and all of that kind of stuff. So I'm kind of in the unique situation of being kind of a guru in those fields and yet no longer behooven to those fields because I have stepped away. I'm no longer employed in academia. I no longer work as a professor. Now I look in the mirror and the boss is myself and I say, good morning, boss. What shall I do today? And usually I respond with, well, perhaps you should stay in your house coat all day and stuff. So no, I guess the benefit is I can say what I want.
Yeah. But if you're backed with all the knowledge, and this is
all
one of the
knowledge,
things.
Yes, all of it. Yes.
Yeah, well, the knowledge that we need to address these questions. So, right, okay, we'll start with an easy one. My cholesterol's gone up, my LDL's gone up, and my doctor, physician, nurse practitioner is insisting, and this is the other thing that I've noticed, especially in the last 6 months, insisting that I take a statin or something similar. And I'm actually getting messages where people are saying, and they are actually saying to me, if I don't take it, they will stop treating me.
Right. Good. Okay. That's a good place to start. First of all, as the patient in the patient-doctor relationship, you are the employer. The physician works for you. If you're in a country like the UK where His Majesty's NHS is nominally, running the show, or think they are, you are still the employee because that's taxpayer funded. So if you pay your taxes, you are the employer, you are in charge. The doctor is there to give you advice on various aspects of your health, should you see the value in that advice and should you decide for your own sake to take that advice. Now that's your funeral if you want to do that. Personally, the last thing I would do is take health advice from an allopathic physician on pretty much any aspect of health. That's my personal call. Having trained more physicians as an academic trainer of physicians, among others, than most people have had hot feeds. I know what goes on in their training. I know what they're taught. I wouldn't take advice from those people, frankly. If you choose to, that's your call, but you need to understand that that is your call. A physician has no business whatever insisting upon anything or insisting that you do anything whatever at all. They have no business saying that. And if a physician says to you, I'm going to strike you off my customer list if you don't buy the goods I'm telling you to buy, well, then I would say, you go ahead and do that. Transfer my records today. You are fired. How dare you? How dare you? How dare you, I'd say.
Yes.
Yes.
You
With your
cad.
empty promises and your drugs that will not help.
Yes.
Yeah. So, yeah, look, statins are, make no mistake, statins are a contraindicated metabolic poison with no established benefit of any kind. Those are the facts. Anyone that tells you otherwise is ignorant, or they are willfully misleading you for pecuniary gain, or both. Statins are, let me say that again very carefully. You can write this down word for word. Statins are a contraindicated metabolic poison with no established benefits, period.
Yes. Now, the thing here, you see, currently there's a thing about statin deniers
Yes, statin deniers, good.
Yeah. The Mail Online had to make an apology to Zoe Harcombe and Dr. Malcolm Kendrick. And what I find astonishing, absolutely astonishing, is in court what's come out in the emails. You know, even the people that are saying that, you know, it's not true about the side effects actually wrote, although in my family, I'm seeing, you know, relatives having side effects from the statins. So maybe they're onto something, and then still wanting to prosecute them. Anyway, I don't want to get into sort of stuff that's going to get me taken off of YouTube. So going to the LDL thing, I mean, one of the things I always say is it's a 70-year-old fraud. I mean, the Sugar Research Foundation bribed 2 Harvard researchers to say that fat was a problem for the heart rather than sugar. And it seems to me amazing that it's still a theory 70 years later, and there are still people who allegedly, you know, are very thoughtful and know a lot about the subject, still insisting that it's causal. And I just can't believe that. And especially when the facts seem to be that people with heart attacks, over 50% of them either have normal or low LDL cholesterol. I know it isn't cholesterol. They're talking about low density lipoprotein, but this is how people talk, that their LDL is normal or low, and they still get heart attacks. It's just, I don't get it.
Okay, write this down as well, anyone that isn't sure. LDL, cholesterol, any fraction of the LDL, any specific lipoprotein, any of those things that you want to point the finger at and say that's the cause of heart disease, you're wrong. None of them are, period. So we've got a drug that acts not only on the thing it's supposed to act on, but also on a bunch of other things that cause problems. That's why statins are so bad. But you've got a statin that works on a thing that's supposed to prevent a disease process when it's not that thing that causes the disease process in the first place. What is this all underpinned by? Money. Statins are one of the most financially successful drug classes ever produced. More money has been made off statins than any other drug, pretty much. And not at any time have statins ever been indicated for use. They have been a contraindicated metabolic poison the whole time. This is a criminal enterprise, a criminal cabal of the highest order. Just the facts, though. Sorry about that.
That's okay. So what is the role of LDL and the cholesterol therein?
Got it. Okay, so LDL is a transporter, if you like. It's a way of encapsulating hydrophobic, non-water dissolving things like fats and lipids so that they can be transported in the blood, which is water-based. Fat and water don't mix. You see how they sit on top of, you know, the fat sits on top of the water. They don't mix. The same is true in your blood. And if you want to move fats around in your blood, you've got to somehow get them to interact with the water and get it to dissolve in some way. So really, if you think about it that way, the LDL is the emulsifier. We think of it as a carrier. It's the thing that these are little packages that contain lipids of cholesterol and fat and all sorts of other things so that they can be transported around the body to where it needs to go to do what it needs to do. The lipoproteins, including LDL, all exist precisely because there is a length of DNA that encodes for their production. Were these things problematic for us and the cause of our death, then positive and negative selection pressures would come to play, and those things would be wiped out. They're not.
It's just sense, isn't it? It's
Mm.
just common sense.
Mm.
So we've got these things, we've got cholesterol molecules inside this carrier that allows it to go through the bloodstream.
Mm-hmm.
So that there's obviously a reason for that. What is cholesterol doing then? This
All right.
apparently dangerous
many
thing.
things. Yes, many things cholesterol does. The first example I always go to is that cholesterol makes up 50% of every membrane of every cell in your body. So lower your cholesterol at your peril. Why would you do that? Other than because somebody in a white coat told you to, because they were paid a lot of money to tell you that. And in fact, they were threatened and browbeaten to tell you that on, threat of having their medical license removed if they don't tell you that. So that's why they so fervently tell you that and insist upon it, because they're required to. It's nothing to do with your health at all, actually. It's to do with their financial well-being. That's why they're saying it. So 50% of every cell membrane, 60-something% of your brain is molecular cholesterol. So again, reduce that at your peril. Go for it. Testosterone, estrogen, both based on cholesterol. Pretty important stuff. The myelin sheathing on all your neurons, the very thing that allows you to function, your neural system to function. That's cholesterol as well. It's also a step in a pathway to many of the prenulated proteins, which is starting to get a bit more technical now, but that's fine. I could go on all day. Here's one, vitamin D. Vitamin D is based on the cholesterol backbone, if you like. And vitamin D is required for basically every other metabolic reaction in your body pretty much as a cofactor.
Yeah.
The act of attempting to lower your cholesterol pharmacologically is inane, nonsensical, dangerous and contraindicated, and you should not do it under any circumstances.
I think that's pretty clear. One of the things I like is common sense. If you eat less cholesterol and you forget all the medications, your body makes more.
That's
and
right.
I think to me, that
it's pretty clear, isn't it?
Your body needs it because it doesn't make stuff that's going to make things worse for you.
Yeah.
I think we've nailed that one. I'm pretty happy with that.
Cool. Let me just say one more thing about statins before we do move off it though, Stephen, because I think this one's also pretty important. Cholesterol is biosynthesized by the human body according to requirements. When you're not eating enough, your body will make more according to the instructions that your genes are receiving via being placed in an environment in which those genes are placed at any given time. All right. It is made from a base starting point ingredient called acetyl coenzyme A, which is the first intermediary of the tricarboxylic acid TCA or Krebs cycle. The drug, the HMG coenzyme A reductase inhibitor, statin, works about 2 or 3 steps up the chain from acetyl coenzyme A in terms of the production of cholesterol from non-cholesterol precursors. Cholesterol itself is about 2 or 3 pages downstream of that in the KEGG pathway. When you look it up online, you go, oh, right, where's cholesterol from this point where this drug is working? And it's like 2.5 pages further down on this page, the next page. Oh, there it is there, all the way down there. Everything in that entire tree, all the different things that your body generates, they are all knocked down by a statin. That is really, really Russian roulette. And if you want to take a statin, as I say, it is your funeral.
Yeah. And I think what's interesting from my research is that the pharmaceutical companies have tried to raise HDL with drugs, have tried other things, and the only thing they seem to be able to do was lower LDL. So it seems like they've tried to mess around with the lipid panel in other ways, and the only way they can do it. And there is documents about this where they were looking at a different process. They were originally looking at the thrombogenic theory and really getting into it, which is interesting. I think that's something that you feel is possible as a reason for heart conditions?
Well, it seems pretty clear to me based on what, look, let's take a step back. Biochemists, those in the medical profession and associated professions, etc., at large, tend to not have a skill that I picked up in one of my earlier specialisms before I moved to cardiovascular pathophysiology. When I was studying the physiology of rest and exercise, that was my first undergraduate degree several decades ago. We had this thing, we were studying biomechanics. We were studying how to learn complex movement skills as part of that. It was the old thing they used to call it biomechanics. And we had this thing we had to do where we had to put together what was called a deterministic model. Meaning that we had to explain successful completion of a physical skill using a diagram where in every circle was entirely explained cause and effect deterministically by what was feeding into it from the above level. Biochemists don't do that. They throw you a metabolic pathway chart and say, look, this, and they'll look they'll look in a reductionist fashion at one or two reactions within this entire cycle or tree or whatever it is in the biology and say, because this and that, then the other thing, without looking at the whole thing. So they completely miss the point in terms of how it actually works. So yeah, the deterministic approach is the best approach in terms of looking at these pathways, what causes, what causes, what causes. The problem is that it's very difficult to get ethics to put people in labs, lock them down, place them under control and observation, and manipulate aspects of their metabolism to see which of them die. Ethics committees tend to not like that kind of thing. So that's the real problem here. That's why we get away with all this shady hijinks behind the scenes and, mandating physicians to lean as hard as possible and harder again on patients to tell them they must absolutely take this drug, otherwise they're going to die. And, do this alarmist nonsense.
And it's frustrating because there are other clues. You can be Sherlock Holmes about this and say, right, well, where do the plaques form? And it's always in a high pressure area. It's always in the arteries. It's not in the veins. It's always where there's turbulence in the blood flow.
Exactly. And that ties in the deterministic thing, because if you say, okay, what is an atherosclerotic plaque? i.e., how is it made up histologically? What if we take samples of plaques and look at them under a microscope, what's in them? Because we're told that these things are cholesterol-rich, fatty deposits blocking up the arteries is what we're told, aren't we? Well,
we are told that. Yep.
When you look at an atherosclerotic plaque under a microscope, what you will find is that it's 95% scar tissue. And it's less than 1/10 of 1% cholesterol or cholesterol esters. So they're not cholesterol-rich at all. That's a lie. We're also told that the cause of these things is cholesterol, which is also a lie, because if it was true, then atherosclerotic lesioning would occur on the endothelium evenly. It would be geographically evenly dispersed throughout the vascular tree, wouldn't it? Because the vascular tree carries the same volume of blood. The same blood courses past all of the different areas in the vascular tree, so they should all be affected by this causal cholesterol in the same way. They're not. Lesioning occurs in very clearly defined, very predictable patterning that Stephen's just outlined. Number one, it does not happen in the low pressure side of the vasculature, in the venous system. Does not occur. There's a dead giveaway right there. There's a clue, because veins carry pretty much the same blood as do arteries. There are one or two differences, the oxygenation level, sure. But the bigger difference is the pressure. God, it is early, isn't it? My brain's ahead of my speech. So yeah, you've got no lesioning at all on the low pressure side. It's only the high pressure side. So now we know deterministically that atherosclerotic lesioning requires pressure or something associated with the pressure. What we do know for sure is if you have low pressure and laminar flow of blood, you do not have atherosclerosis, despite the fact that that blood carries cholesterol too, the same cholesterol pretty much, at the same concentration pretty much too, actually. Yep. Interesting. Then we go, well, okay, so it's a pressure issue then, is it? Well, no, not directly, because if it was a pressure issue, then atherosclerosis would develop evenly on the high pressure side. Does it?
And it doesn't.
No. Whoopsie. So there's that one out the window. There's something at a level of determinism higher than the pressure itself. Turns out it's turbulence. Areas where flow is turbulent in the high pressure side of the vascular tree, which is in the larger vessels, not the smaller ones. It's at the highest end of the high pressure. Yep. And it's at points in the vascular tree where you've got bifurcations occurring, or when you've got big arches like the aortic arch, for example, where you will find atherosclerotic lesions occur around one side of that arch and not the other, because it's the turbulence, it's the delayed transit, it's the elongated transit time of the shear pressure of blood that causes the issue. Deterministic tree.
And there's got to be some injury.
Yes.
Isn't there got to be an insult to the vessel?
There has to be an insult to the endothelium before the endothelium will encapsulate and retain lipoprotein packages. They have to become oxidized, glycated, or both for there to be a problem, because your body will not react to a native protein. You have to derange the protein before your body will recognize it as an invading protein. So there's a cascade of events that has to occur to cause atherosclerosis, which ostensibly has absolutely nothing whatever to do with cholesterol, and very, very little to do with the lipoprotein carrier.
Well, I think we've covered that. I'm happy.
I'm glad. I wish that would be the end of it, but it won't be. I'll tell you why. Because what I've just told you, while being absolutely true and unassailable, cannot make anybody any money. There's no way to make any money from that information at all, because I can't sell you anything. But if I can sell you a drug that will lower your absolutely causal cholesterol, well, then that's the way I'm going to go. It's sad,
to me, it's and to me, it's the common sense that if I came up with a theory 70 years ago, I'm only 60, I know that couldn't happen, but 70 years ago, and it was fraudulent and proven to be fraudulent, I don't think I'd be sort of hawking it around now, because it's never been proven in 70 years, and the drugs are not effective. People are still having heart attacks, and you get the vegans, vegetarians, all different ways of eating. They still get heart attacks. They avoid all these things they're supposed to avoid. They still get heart attacks. Anyway, right. That's great. Thank you for that.
Cool.
I appreciate it. The next one, which comes up, is, so you don't eat veg, you don't eat fruit, you can, and the person put insert random food. let's just look at fruit and veg. They're going to say you're not eating fruit and veg. You're not. That can't be healthy. What would you say to people?
Well, first of all, I understand exactly why people say that. So, it's not a judgment on anyone who has said that at any stage, or indeed who still says that. Other than what I would do is throw this challenge to you. Who told you that? Seriously, who told you that? Probably it was your parents.
Let's play devil's advocate. I saw it on the telly.
Yeah, all that. Well, it must be true if it's on the telly.
Yeah,
must be. Absolutely. Everything you see on the telly is true. Of course it is. Look, everybody is told that. It is one of those, I'm loath to use the word, but I will. It's one of those lies that is repeated so often with such conviction that it just simply isn't even challenged anymore. Oh yeah, fruits and vegetables are good for you. Of course they are, because I've heard that 1,000 billion times in my life. So it must be true. Well, it's not true. Sorry about that. Again, let's just go with facts, because facts are my thing. I like facts. Here are some facts. There is nothing that you will find in fruit or vegetables or plant material of any kind that you require nutritionally to live a long and healthy life. Not a single thing. Let me turn off my phone alarm, which is telling me to wake up. Too late. That ship has considerably sailed. I woke up some time ago. Goodness gracious. Where was I, Stephen? Sorry.
Well, it's a lie. You're saying it's
a lie.
Yes,
the lie of fruits and vegetables containing things that you absolutely must have and must get from your diet to be healthy and live a long life. No, that's not true. There's not a single thing in fruits or vegetables that you cannot get from meat and animal fat that you need. Let's come up with a buzz term, though. Let's call it phytochemicals. Oh, yes, the plants contain phytochemicals that you must have. No. Which one? Name me a phytochemical that I can't live long and healthy without. Shall we wait?
I can't.
People don't challenge. People don't ask questions about what they're told. People accept what they're told and go, oh, okay. Fruits and vegetables are good for you. No. Vitamin C, though, I guess that's on your question list too, so we'll leave that for now.
Yeah, we'll come
fiber,
to that.
Though, they'll say. Well, okay, that's on the list too, probably, isn't it?
It is. Vitamin C, fruit.
Good.
They all go together. I mean, one of the things I always point out to people is fruit and veg are not there 24/7, 365 days of the year. So what did people eat when there was no fruit and veg? I mean, what did they eat? So for what, for 6-7 months, they went without these vital phytochemicals, which is.
Oh, look, I was just looking at a picture of a cave painting the other day, which showed people trucking and planing in and shipping in produce from the tropics all year around to deliver to their caves. Absolutely.
Yeah. I have never seen
pictures of salads that they were preparing. And over in the corner there's a group of other men standing around with their calculators, making sure that everything's right for chronometer.
Well, you preempted the next couple of questions, so let's do that. Let's let you flow on vitamin C and then move in. No, let's do fiber first, because it goes on from fruit and veg, and then vitamin C.
Good. Okay, just the facts again. Right. The exact dietary requirement for fiber in a human being, dietary fiber, not 1 single gram ever, none at all. Do you need fiber so that you can do number 2s? No. Is fiber required for that? No. Okay, so they'll tell you it is. It's not. If you doubt me on that, what we'll do is slowly transition you, not change your diet overnight, because that will mess you up, but we'll slowly transition your diet to one that contains no fiber whatsoever over a few weeks. And what will actually happen is universally your bowel function will improve vastly. There will be less volume, there'll be less regularity. You won't necessarily go every day at first, but you're not constipated and there's not this bulk of stool that's not moving. It's just that you don't actually need to be excreting something that you didn't need to eat in the first place. So there's that. Fiber, it seems, if anything, is likely to cause bowel dysfunction, perhaps, rather than actually sort bowel function out in any way. There's really only one clinical or pseudo-clinical study in existence on this pretty much anywhere in the literature. It's a study of, I think it was N equals 62 or something like that, 63, I can't remember the exact number. So it was a relatively small-scale study, sure, but what they found was that there was a dose response in their population of idiopathic constipation sufferers, whereby a partial removal of the fiber led to a partial recovery of their bowel function. A complete removal of the fiber led to a complete recovery of all symptoms of constipation, stress, strain, anal bleeding, and all the rest of it. 100% of cases, all the time, every time, without fail. Interesting. So there's that. We don't have a cecum, an effective cecum anymore. That is now a vestigial organ. It's called the veriform appendix. It plays minor roles in your immune system these days, but certainly we don't have the capacity to be breaking down much fiber at all and producing much short-chain fatty acid out of that at all. In fact, fiber is a passenger that goes through your digestive tract pretty well untouched, and you then have to pass it out the other end at considerable effort, stress, strain, and damage to your colon. It is not supposed to be there. Our colons are designed for a hypercarnivore diet. Designed by natural selection pressures over millions of years is what I mean by designed, by the way.
Yes. We'll come back to that point. I want to throw in something here. And I know you're going to laugh about anecdotes, but I prefer to yeah, anecdotes. Clinical experience. I mean, I've now got over 1,000 clients, and I do not have one that has trouble pooping. They might do initially. They might have a bit of diarrhea. They might have a bit of what they think is constipation. But once they're sort of adapted or been eating this way for a fair amount of time, I can't think of anybody that's into this at least 26 weeks or more, and they have trouble, toilet troubles. What I would say is I think that's one of the biggest things that is problematic, is because people are deliberately saying clinical experience is not as important as evidence-based studies, these sort of things. Well, I can't think of anything that's actually better than thousands of people following something and proving that what the mainstream is saying is not true. And this brings me on to vitamin C, because I have yet to encounter anybody with scurvy. I know that's a really simple thing to say, but that's obviously one of the big symptoms of a lack of vitamin C. So my eyes, ears, and experience, and I've been 5 years at carnivore coaching, 10 years low carb keto coaching. So that's a decade. No one's ever had scurvy. And don't forget, I do a lot of bloods as well. So what's your take on this myth, which it clearly is, that you would be lacking in vitamin C?
Right. Well, just that. It's a myth. At the most basic, most simple argument, you've just made it. Well, show me a bunch of carnivore eating human beings who get scurvy. Show me one anywhere in the world. Good luck, because there aren't any. Not one anywhere in the world. Doesn't happen. Why not? Well, when you need to absorb vitamin C into a cell from the blood, it needs to be transported into the cell from the blood. There's a protein transporter that's involved in getting the vitamin C into your cells. Tell us what it is, Steve.
What, that competes with vitamin C?
Tell us what the transporter is.
Well, it's a glucose transporter, isn't it?
Right, it's GLUT4.
I don't know.
Exactly.
Yeah, GLUT4. Yeah.
It's the glucose transporter. It's the same one. So here's the deal. If your blood contains a bunch of glucose and some vitamin C, the glucose is going to outstrip the ability of the vitamin C to enter the cell via that transporter, because it's going to outcompete it, because the concentration of glucose is always going to be vastly higher than the concentration of vitamin C. So therefore, a person who eats a bunch of carbohydrates needs to intake a bunch more vitamin C than a person who doesn't. Because the person who doesn't has less glucose in their blood chronically, ergo less competition cross-inhibiting the uptake of vitamin C. So the vitamin C requirements of a carnivore eating person are vastly less than a person eating carbohydrates. That's why
Yes,
we
and
don't get
also,
scurvy. And because there's plenty of
yes,
vitamin C for our requirements as a species to be found in the muscle meat of large ruminant animals. The
yes,
very thing we evolved
which is,
eating. Isn't that amazing?
yeah, yes, which I think the research of Ambro Hearn was very interesting because
Mm,
there are still nutritional facts out there, databases that say there's no vitamin C in red meat. And every time she challenged this assertion,
mm.
they literally, yeah, you love that word,
Literally,
literally said, well, we just assumed it. And
yeah.
these are people publishing alleged nutritional facts,
Yes,
not even checking their own facts
that's
that they're
right.
putting out.
Oh, look, you'll
Yes.
find 95% of assertions made in the peer-reviewed literature are actually not facts.
Your opinions.
95% of it is not repeatable.
Mm.
In other words,
Quite worrying.
you give a research team someone's paper that they've published, and you say, right, you're a researcher, they're researchers, here's their methodology, repeat this, cookie cutter, and see if you get the same results. Nope.
No.
95% of the
No.
time.
Yep. And that's a big deal with science because
Mm,
experiments have to be replicated,
that's right.
repeated. And anyway, right.
Mm,
That's good. Well, I'm going to go off topic a little bit more from my list because you mentioned about what we've been eating for thousands of years and we're designed to. So, do
mm.
you want to just do a little section on stable isotope testing?
Yeah, sure, can do. So when I say, look, human beings have been eating the muscle, meat, and fat of mostly large ruminant animals for millennia, how on earth would I know that? I wasn't there. I'm pretty old, but I'm not that old. So how do I know what people were eating thousands of years ago, tens of thousands of years ago, hundreds of thousands of years ago? The answer is, it turns out that when a human body decomposes, inside the long bones that remain for many, many, many millennia is viable collagen, which is a protein that you'll find in the long bones. That collagen is a protein that we can test for stable isotopes of nitrogen. What do I mean by stable isotope? I mean it doesn't radio decompose from one form to another over time like carbon does. So we use carbon to date something. How many years old is the skeleton? And then we use nitrogen to find out what that person ate during their lifetime, be that 100,000 years ago or 10,000 years ago or whatever, because the nitrogen isotopes in that collagen are stable. The thing that informs the nitrogen isotopes in your collagen in your body is the makeup of your diet in terms of plant materials versus animal materials. It gives you a trophic level, it's called, as, how high up the food chain are you? Very, very reliable, very scientific, based on actual first principles, actual physics, the knowledge of actual physical things. And I do that because physical things aren't a reality either. That's for another day. And the tests from collagen from human skeletal remains and pre-human skeletal remains as well, that goes back several 100,000 years, they all agree within 5% of dietary makeup. And they all say human beings consumed a diet which consisted of 80% or more meat and animal fat, and 20% anything else, up to 20% anything else. We are obligate
Simple.
hypercarnivores. Simple.
Yep. Just simple.
Mm.
Right. I've got three more questions. How are you doing for time? You
I'm
doing
okay today, Stephen. I've got a gap after this until the next thing. It's amazing.
Oh, that's good to know.
Mm.
That's good to know. Right. Okay. So the next one is a real chestnut, and sorry to sigh when I say it, but I do because I've got hundreds of success stories of people improving their kidney health, but the myth prevails. Surely eating all that meat is going to be bad for your kidneys.
Right. Well, give me the mechanism then, would be my first question. Okay, great. Eating a lot of meat is bad for your kidneys. Tell me how that's so.
Well, I'm going to actually again play devil's advocate because I
Please.
don't want people out there thinking I'm asking these questions because I believe it. So I'm making this clear. They'll say, well, there's protein in my urine. That's honestly what they say.
Right. Okay. So what causes someone to have protein in their urine? Usually, if they've got protein in the urine, what's the usual cause?
Well, the body is excreting that protein, and obviously they've got to have some reason to do that.
Right. Okay. So either the body is taking in too much protein and it absolutely doesn't need it, in which case, why wouldn't it excrete it in the feces rather than through the kidneys? Secondly, are we talking about whole proteins coming out in the urine?
No.
Or is it remnants of protein in some way? Well, that's the second. It's usually protein remnants and stuff, whatever. Let's cut to the chase. A person who has dysfunctional kidneys may experience the leakage of more of this kind of stuff in their urine. Sure, they may. Absolutely. Does that mean the protein was the cause of the disease process in the first place? Again, let's look at this deterministic thing. Given that a human body, the dry weight of a human body is vastly more than 2/3 protein, why would eating that very material from which our bodies are made be a problem to us in some way? Inherently, if we are otherwise healthy and functioning normally, if you have normal, physiologically functioning kidneys, what I'm telling you is no amount of protein eating will have an effect on that. You cannot cause kidney disease by eating protein. If you have kidney disease for some other reason, then there might be a reason for you to manage your protein intake in order to subserve the needs of your disease process at that time. Sure. But that doesn't say that eating protein was the cause of the disease in the first place. It wasn't. It's just one of those things that partial half information that a basically deeply evil and misanthropic organization will latch onto to try and sell people the idea that you need to be afraid. You need to be in fear of the very foods that will keep you younger, healthier, stronger, better, and faster, and make you more able to resist the deep state. I know I'm going off on the tinfoil hat side now, but basically at the end of the day, without any of that last bit, just the facts.
So what would you speculate is the major cause of kidney damage then?
There are a number of things that are pretty high on my hit list of probable suspects. I'm going to go with oxalate damage being almost entirely certain in a person that's eaten any significant amount of plant materials at any point in their life. I'm going to go with chronic systemic inflammatory process through, other anti-nutrients, toxins and things contained almost entirely by plants. I think those are the two real big ones.
Yeah, I think they are. Yeah. I'm not asking you to, be encyclopedic here. I'm just, like I say, playing devil's advocate of the things that come up constantly. Not worried about salt intake then as a
not
big
remotely.
player in this?
No. Much like thirst and hunger, the human system has evolved a means of communicating with us, not using words because physiology doesn't have words. Words are a human invention. Language is a human invention. But physiologically, behind the scenes, our brain can communicate with us about what it needs by giving us a clearly understandable, geez, I fancy some salt feeling.
Yep.
The same is true of hunger and the same is true of thirst. If you are eating the right stuff and drinking the right stuff, you can mess up your instincts by eating poisonous things that aren't food, like basically everything from the plant kingdom, it turns out.
Absolutely.
Yeah, not food for
Yes.
human beings. They will mess you up in more ways than you can possibly imagine. Inflammation, anti-nutrient status, toxins of all sorts. We could talk all day about the evils of plants in the human diet. But at the end of the day, if we're just sticking to the facts, then, I mean, I guess I've already given them to you.
Would you want to guess the next question?
So we've covered vitamin C, though. We've covered fiber, though. We've covered... I'm off. I'm off track. You tell me.
Yeah, that's okay. That's all right. It's early in the morning there.
Yeah.
What about tanking your T3?
Oh, yes, the thyroid issue. Yep.
Yes.
Okay. There seems to be a connection between a person who eats very, very low levels or zero carbohydrates to speak of, and who also does not eat sufficient protein. Those people tend to end up with thyroid problems, electrolyte problems, muscular problems, all sorts of things. Simply because the human body, while it is not evolved for consuming carbohydrates, and while carbohydrates are required in exactly not 1 single gram ever, you do need protein. And people tend to underdo it at large on protein, especially people who are following a ketogenic lifestyle, because everybody who's a ketogenic lifestyle advocate understands that if you eat too much protein, then you will be kicked out of ketosis. And so they avoid eating protein as well. They have high-fat diets that are too poor in protein, no carbohydrates to speak of. Well, it's no wonder your thyroid system falls to bits. Get some protein into you. A minimum of 2 grams per kilo of lean body mass per day, preferably in 1 bolus. Minimum. Now, there is such a thing as too much protein as well, but that's not today's concern.
Most too much anything.
Well, yes. Too much water. Too much oxygen will kill you.
Yeah. Too much of anything.
Yeah.
Right. Well, I'll clue you in on the next couple then, because as I now know you've not got to rush off. There is a couple of other things I wanted to cover, so I'm going to cover them now. What about slight elevation of ALT and AST on this way of eating, especially if you train and work out? That seems to be something that people worry about. Again, plain devil's advocate, it's not something that worries me, because you need some other markers as well and some context. But
yeah, look, people often come to me clinically and say, "Oh, look at my bloods, look at this, look at the the liver function here," for example. To which I go, "Geez, that's interesting. Tell me, what symptoms are you experiencing that would lead you to believe that your health is compromised in some way?" Well, nothing. I've just got these blood results. I feel fine, but I'm concerned about these blood results. And I'm like, well, what do you think the interpretation of your blood results are based on? I don't know. Well, let me tell you. What they'll do is they'll compare your ALT-AST ratio, if you like. It's a quotient rather than a ratio. But anyway, that's for another day. And they'll compare you to Joe average, to a population average, and see how many Z-scores, standard deviations, or whatever you are away, high or low, from the average value of the population. That's what they do. Well, let me ask you this, Stephen. Why on God's green earth would you want to be average on anything related to health?
I want to be optimal. As near as possible.
So let me ask you again, how do you feel with this elevated ALT-AST?
Well, strange enough, I have got elevated ALT-AST and I feel fantastic, and I do work out.
Right, are we done then? I think we're done.
Sorry?
I think we're done with that.
I
think we're done with that one. Look, the same thing is true of any blood value that you'll get. People are absolutely fixated on testing their blood and getting results on their blood, and then they interpret the results based on what's average and make a judgment on whether they're doing the right thing for their health or not without reference to how they feel and how they perform and how
Yes.
they interact with the world and stuff.
Yes.
What
I
are
had
you
this
doing?
last week. Yes. I had this last week. A client sent me their bloods, a full panel, well woman, all that sort of stuff. I looked
the
at them.
worried well. Yes.
Yeah. And she came online and I said, I've looked at your bloods and they're perfect, aren't they? How do you feel? And she went, terrible.
Yeah.
So, yeah, because they were all
on
in
average,
range.
people feel like shit, don't they?
Yes.
Yeah.
So, yeah, I'm totally with that. Right. So I'm going to ask a couple of bonus questions, and if that's all right. And then when
Absolutely.
we get off the recording, I've got two things I want to show you, which I think you'll be interested in.
Okay.
Right. Okay. Ozempic. What are your thoughts on that? The miracle weight loss drug.
Yeah. GLP-1 agonist.
Yes.
Yeah. Okay. The reason that 99.99 something% of the time, and that's the number I just get a guesstimate. That's not tapping data, so don't get too excited, folks. I'm just saying the vast majority of the time is what I really mean. A person with elevated blood glucose chronically, someone who is defined by reference to their normal, to the average normal as being a type 2 diabetic. The reason for that is because the cells of their body are not accepting glucose from the blood as a fuel source. The sugar is locked out, if you like, from being used. Why is that? Well, because there is perfectly sufficient energy containing substrates, if you like, carbon skeletons already there that the body can use for oxidative purpose in the form of fats. Fats and sugar tend to cross-inhibit each other in terms of entry to the mitochondrial energetic pathways. It's a thing called the Randall cycle, which I'll be doing another updated video about soon, because the more I study the thing, the more I realize how little I understood about it before. So I'll do another video soon, which brings yet more of it to light, I think. But anyway, at the end of the day, what is happening the vast majority of the time when someone's blood glucose is elevated is because that situation is in effect and those cells are not accepting glucose. And that's a good thing, because too much glucose inside a cell will destroy that cell. It's poisonous.
Yes.
So we need to
Toxic.
lock it out. Of course we do.
Yeah.
And that's what the body does. Again, it's dictated by a mechanistic bit of kit, if you like, piece of machinery within the metabolic machinery, which is a physical thing, that disallows this. It's a self-protective thing. It's not a pathology. Most people will call it insulin resistance. And they'll say, it's the underlying pathology for diabetes and such like, and all of that. Absolute, utter, gut-rotten nonsense. It's nothing of the sort. It's a developed self-protective mechanism that is indicated useful and, should not be looked on as any kind of pathology, let alone that it should be rectified by giving you a drug which basically circumvents this Randall cycle mechanism and forces that cell to drain the glucose out of the blood into the cells. Great, we solved the high blood glucose issue. Yes, but you've also compromised every cell that you've forced to absorb sugar that it doesn't want in so doing. Here's a drug that does what it says it does. We can charge people billions for it. We've solved your high blood sugar issue. Great, but we're going to kill you just as quick by destroying your cells with glucose. It's criminal. It's as criminal as the statins we were talking about earlier. It's all based on the arrogance of thinking that we understand human physiology better than 4,500 million years at least of evolution.
It is exactly that. It's arrogance. It's reductive thinking, and it's nonsense. Right. I'm gonna end with a really simple one.
Good.
And again, it's as soon as I say it, you go, yeah, that comes up a lot. Leg cramps.
Yep.
I'm getting leg cramps because I've gone this way I started this way of eating and I'm getting leg cramps. What's going on?
Again, just to make up the number 95% of the time, most of the time, vastly most of the time, leg cramps are a situation with an imbalance of magnesium at the muscle, specifically magnesium. The solution is a teaspoon or two of Epsom salt dissolved in some water in a spray bottle, and that being sprayed directly on the skin. Fixes it up a treat. Usually happens in the first year or two of someone being carnivore. Almost invariably, it's to do with having changed their diet from one thing to another thing too suddenly. I think I'm about the only advocate online who has 50,000 subs or so, who's actually saying this to people. Don't just change your diet overnight. Don't do that. Don't do that. I know some of the bigger or more subscribed advocates of carnivore diet are just telling people, don't worry about it. Just do it. Go carnivore yesterday. It's great. I don't agree. I think that's a bad idea.
Yeah, I think a slow transition is best.
Yes, absolutely. So anytime you want to change your diet from anything to anything else, my advice would be to do it slowly.
Well, my analogy is actually based on when I was younger. I was actually a ski rep and I trained people to ski. Well, imagine me saying, well, it's great. It's easy. All you do is you're on 2 planks of wood, basically, and you're going down a hill on the snow. So let's start on the Olympics slopes. Let's do that.
Yeah.
Awesome. It's like, well, that's just going to injure me and be ridiculous stress and everything. So let's just do it nice and simply and go up, you know, one height, then the next height, and then the next height, and just do it over the next 2 weeks. And by the end of the 2 weeks, it'll be a dream to go on the Olympic slope. It won't be a nightmare that you'll never get over.
Yeah.
So I think you're wrong about that. I think we, Richard and myself, when we do our lives, we always tell people to consider to do it slowly, to transition slowly.
Look, I know absolutely that there are people who watch my stuff, who subscribe to my stuff, who also have channels who say what I say in that regard. And that's great. That's awesome.
Yeah.
I guess what I was referring to is those
big ones,
guys and some of the ladies who have, you know, like 100,000 or more subs, some of the really well subscribed, very popular folks.
I know.
Most of them are saying, yeah, just do it. It's great. It's awesome. And several of those have medical degrees. So
I know.
Whatever.
Well, one of the things I was neatly yet wrapping up the 60 minutes with some common ground, because there is also another bit of common ground. On top of my medals there, you will see Collagen Active and my Stem Enhance.
Excellent.
Yes. I know it's not like your big posh logo you've got there. I want to thank you for getting me into the Stem Enhance, because it was a game changer for me. I kind of was amazing, and I think Stem Enhance was like the butter on the steak. So I just want to publicly thank you for that. I think it's been a game changer for me, and I've gone up the dose after speaking to you last.
Awesome.
And it's been amazing. So Bart, thank you for that.
My pleasure.
I've got a couple of. I'm going to keep recording if you don't mind, because I want to show you a couple of things.
Yeah.
And you might go, oh, I wish you'd recorded that.
Right.
So
you're going to. Good.
Yeah, well, you might do. This happens ever such a lot in other fields. So let me just see if I can get this up for you. This is from a real person, by the way, and it's just a thought experiment. I think that's clear enough. Got his name on there. I don't think that matters too much. Let me just find it without his name on. Bear with me, mate.
All right.
Yes, I think you'll like this. I really do. Come on, where is it? It's a thyroid reading, and I think it's just fascinating how the guy was told that he was subclinical, and actually, during the coaching call, I said, well, let's do a thought experiment. I'd like to show you, because I think you'll appreciate it. It's great when someone has a lot of data and then you can make an assumption from it. So can I screen share? I think I can screen share.
Yes.
Oh, no, disabled, it says.
I might have to give you permission.
Please do.
Let me find where that is. It should be that. Advanced sharing options. Multiple people can share. Try that.
Well, it'd just be me.
Mm.
Right. Am I ready to share?
You should be. If you press share, it should happen. If
Let's
not, we
do
can just talk
this.
it through.
Okay. Nothing beats showing you though, mate. Honestly,
Yeah, I understand that. No, it's one of the intricacies of. There we go.
think
There it is. Very good.
yes.
Yes.
Right. Now, he actually came to me because he was really worried because his doctor kept saying, my TSH is subclinical. My TSH is subclinical. All right.
Right.
So for the people that can't read what it's saying there, the thyroid stimulating hormone, the range should be 0.4. I know it shouldn't be. I'm just saying it's what they say, 0.4 to 4.
Mm-hmm.
And it is technically subclinical. And he's been doing this for 4 years. And this is from 2020 right up to 2023.
Mm-hmm.
And his T4 is always pretty much right in range. Again, I know that's sort of pejorative, but it is in range. And his T3 was in range when he did measure it. Now, I actually said to this guy, let's imagine you're the first person that's ever had bloods taken, the first person, right? What is the purpose of TSH? And he said, well, it's to make T4 primarily. I know there's other things, but primarily it's to make my thyroid make T4. And I said, well, look, if you were the first person that ever had this test and I did it over 4 years and I looked at your T4, forget everything else for a moment, I think, oh, wow, this guy's T4 is always in range. It's fantastic. Therefore, your TSH must be perfect.
Deterministic model.
Yeah, right. Now, but this is really common, Bart. This is one of many where I keep saying the same thing to people. What is the purpose of the thing they're telling you is wrong? And is that outcome wrong? You know, are they right to say you need to increase this? I get this also with insulin. I get this also with blood glucose, many things. And I thought that was a brilliant example of how wrong they can be.
Love it. Yep, that's very clear. Very clear indeed.
Yes. Well, that's what we're dealing with, because that's in the context of this way of eating over 4 or 5 years. That is a functional thyroid. Right. Yeah. That's the first thing. So if you ever want me to come on your show and talk about that, that would be good. And the second thing, and I think you'll really like this because you're into looking at things differently. So you like that one? That's lovely. Good. Right. Okay. This is the second thing then. Right. Let me see if I can get this without the people.
Welcome to Amateur Hour. Talk amongst yourselves.
Yes. Well, I'll edit it. I will edit it. I promise.
Of course we will.
Liver patterns. I had them already, and I don't know what's happened. Well, I do know what's happened. My computer is crap. Right. Here we go. Liver patterns PDF. This is right up your street. Right. Now, because I see a lot of bloods, and like I say, I got a decade of private bloods before I was doing this. Here we go. Let's go to that. Now, diagnostic purposes for liver enzymes. A pattern emerges. Generally speaking, this is the pattern. And this is why I was getting on about the other two enzymes. So you've got AST, ALT, ALP, and GGT. And if you look at bloods and what the outcomes were, which is, the big things we were talking about, if you get all four, then a healthy pattern is like this. Viral hepatitis is like this, a sort of step up, step down, like an interval training sort of thing as you're cooling down. Alcoholic fatty liver is like a step up, and cirrhosis is a fast step up, especially with GGT. But using your thing of 99.99% of bloods I see do not have GGT and do not have ALP. They just have AST and ALT. So they inform you on nothing other than you might need another test.
Yeah.
And to me, I thought, firstly, putting it into a pattern is actually, it makes a quick diagnosis or potential diagnosis. And secondly, why are they not testing ALP and GGT. When it actually comes to liver diagnosis, they have to. I don't get it at all. Because every single time when someone has bloods and they have AST, ALT high, and invariably they haven't started carnivore yet, and they have said, in fact, I have not had one on carnivore that's had a problem. Like they say, I did it just for a benchmark. I say, well, really, the first thing you need to do is get these other 2 tests because it's greatly elevated. So I just wanted you to see that, really.
Awesome.
See that,
nice.
I'm thinking differently. I'm beginning to think out of the box because no one else is doing it.
No.
What do you think of that?
I think it's awesome. That the important take-home message is that not only are your bloods not crucial that you are in range, because who wants to be in range anyway? The important thing is actual function. How do you feel? How do you perform? How do you interact with the world? And if we're going to look at bloods, why don't we look at everything? Because partial information can lead you off on all sorts of wild goose chases, can't it?
Yes, absolutely.
Love it.
And I was going to say, the people that train where it elevates, their GGT doesn't go up. So it tells you, well, there's no blockage, there's nothing really there. It probably is just muscle breakdown and the fact you're intensely working out. So yeah. Great. I'll stop recording now.
Awesome. All right.
That was excellent. Thank you for doing that.
My pleasure.
I shall